Welcome to another episode and video on my Raspberry Pi 1 running Raspbian Linux and connected to network for VNC, virtual network computing, serial port for serial monitor terminal, and band cable to this breadboard for experiments, and in this case experiment on actually only this chip, which is I2C, a protocol that I've been trying to do for the last 2 episodes. This is the third one, I think. And the point is that with I2C you can both read and write to electronics, sensors, and currently it is the idea to write to LEDs in such a way that it is a walking light, which means that one light lights up and goes down, and then the next one and the next one and the next one. I have so far 3 LEDs connected, and then it turns out last time that the algorithm does compile but doesn't work. Not for me, not yet. Originally the algorithm is written for 8 LEDs, and I have written them for 3. Well, I've changed it to 3, but in case for 8 you can use all ports. 3 you can't. So then the question is which way to do the walking and which ports to use. Is it either 0 to 3 or is it 8 to 5 or 5 to 8? Well, last time it turned out that neither works, so nor 0, 1, 2 or 1, 2, 3 or 5, 6, 7 or with whichever 7, 6, 7, 8, it doesn't matter, it didn't work. So how about the signaling? Because here you see 2 probes connected to data and clock, and that doesn't work either. Oscilloscope gives no signal. Well, they do give it does give a signal, but not one that you think, okay, this is nicely working protocol. So now is the challenge to find out where it goes wrong. And since I'm not the only one and not the first one to check on the protocol and the software, it can be a nice challenge. Last thing I did was changing the makefile, because this was the last experiment where I programmed in Python with the ISP protocol, and this is I2C programmed in C, standard C, which brings whole different challenges. So let's have a watch. Let's have a look. So right now I have 3 things open. Well, 4 things. This is the oscilloscope, of course, with I2C. Channel 1 is clock, channel 2 is data, and well, here is still the update, but where it comes to is here. Let's open the make file. This is what I was changing or trying to change last time, and right now it should be working. This is the real file. This is a demo, and this demo I started with, and right now it is from 5 to 8 and from 8 to 5. Doesn't work. So with this, this is for object files, and this is for the real thing, at least. I hope so. Let's see if I still forget something. Nothing else is being done. Usually with the CCC command, -O gives the output. So here it simply says, alright, generate a nice output file, same as I'm doing here. -O is telling the compiler to generate a nice executable, not output file, executable. So let's quit this one and say, alright, make and I could also say make all. Not to be done for all, but it has made a few things. So let's take a look at what I can or should be able to execute. Well, here is, oh really, this is something I did not expect, an executable C file. Let's watch the make file again. That would mean that this file has become a make file, instead an executable instead of a normal thing. That is not really what it should do. And here is another object file. This is the same as here. So why does it behave different? Okay. Let's execute the demo. Well, apart from this happening, nothing is happening here right now. Quite obviously. I could try to change the time base. One-tenth of a second. Still nothing happening. Then that isn't there. And this is really not correct. So I do have to change the make file, because a C file that is an executable, that's not good. Okay, I have executed this file. Oh, by the way, you notice that I have opened a fourth terminal window in which I have opened a make file, so I can now switch and don't have to open each time. It says, well, line 17 makes a problem in here. Yes, I can understand that. Syntax error. Well, it shouldn't even do syntax error because this is a comment. Comments are skipped, thrown out the executable, so only binary is kept. But then it says make all, and then it goes in a make file. A recipe is failing. Well, this is the make file. Then line 30, this is failing. This isn't, this is somewhere, somehow. Then I investigate, okay, what are the properties of this C file, which is this one. This is the C file, the normal C file, not the demo. Read, write, execute, read, execute, read, execute. So it's writable for the user. Then what I did was write everything again into the file to see whatever happens. So I executed it once again and it had exactly the same properties. Then I did the same for the demo. Well, not write, but look for the properties, which are exactly the same. And yet, whenever you look at it, I do have a real executable without extension C for the program, because here comes the output from here, not here, here. Then what does the demo do? It has exactly the same properties, which raises the question for me: why is there no proper executable generated? Like I said, GCC -O gives an output. So let me do exactly the same now. -O MCP, no, MCP 2.3, that one. I want to compile this one, and as an output I want this as an output. Everything has been generated, or should be. Let's see whatever comes from it. And you find reference to main. Well, here is a point. In the demo there's a main. Here there's no main. This program the normal one, doesn't look like an executable at all. It has a function int, MCP whatever in it. So what I should do is actually get rid of this. This one, and then see whatever happens. Not a queue. Okay, make file, make all. There's a target MCP, a built-in recipe that's failed. Where? Okay, so I should go back to the website where I got this and see how the make file has been was originally, because now things start to fail what didn't, and this is clearly now executable. This can't be executable because main is failing. I should have seen that, I should have realized that before, but anyway, since the program ends here and there's no main, yeah, clear stuff. And it's been a while since I played with a makefile in this way, because C, like in, for example, Arduino, is set up completely different. And this is standard C, so it takes a little bit of adjusting. Anyway, let's refresh. Well, I found another thing. I can of course use the tar instruction to extract just one file, and then I made a slight mistake by using only the file name, but I have to use the complete path. So this is the one that I should be using, which works. So let's go to the refreshed makefile, this one, which is the original one. So if I say now make all, that should work. Nothing to be done for all. Then, since I cannot possibly execute this one, I have to execute this one, which hasn't changed. So there we go. It is exactly the way it is, and as you can see, nothing happens. That means that I can just as well shut this one, because it uses everything like this. So now I have to be careful to quit this one out, and this one can go out. No use anymore for now. But this leaves me with the question that I2C BCM 2017.h 2708, is it anywhere near? Well, this assumes that it is in the path. Is it in the path? I2C, anything I2C is not in the path. I2C dev h is not in the path. So when I go to the root directory and I say, okay, find, yeah, where to find it from the root, I2C def h you can probably wait a long time, but it will come down to yeah, except for permission denied, it has to be coming from somewhere. And let's go back one directory. The point is also that this one has the same path as this one, and this is right here, so it's simply missing. Where to find it is another question. So let's go hunt for it, because it might be just a solution. And once again, I am being reminded that the Raspberry Pi isn't just an ordinary computer. Searches on the internet reveals that this and this is just present. You just have to configure the Raspberry Pi to use it. So that reminds me that a long time ago, when I first set up this Raspberry Pi, I used raspi-config program to set it up, and right here in the advanced configuration I encounter, just like I did with SPI, the serial peripheral interface, which is this one, not ISP or whatever, but SPI. There's also I2C. Would you like to be enabled? Yes, and now it is enabled. To be loaded by default? Yes. Okay. So this means that it is now done, and let's see if things now actually do work. I'm very curious about that. So, one way to find out let's actually make all, and once again it's not there, it's terminated. But on the other hand, if it is not really necessary, let's find out this one. Right, it has made it because I changed the source code, but how will it run? And unfortunately I see nothing yet, but now how about this? I am going down to this one. Let's just see whatever happens. Not Q, that quits. Let's see. And unfortunately I have to conclude that it doesn't work either. So it's not 0 to 3, it's not 5 to 8 or 8 to 5 or whatever. I am quite sure that this is now correct. Let's check once again. Advanced options, I2C, yeah, is enabled. Loaded by default, yes. Oh wait, should I actually reboot it to be loaded? That's a very good one. Not quite sure if it is done by now. So for the last part, let's check if that is really what needs to be done now, and then see once again. Alright, one reboot later, and what I just noticed when I rebooted it is that here now there was a signal visible. So now I'm trying for 0 to 3 and 3 to 0, whatever that may be. Will that have an effect? Not that I can see. So I am going to change these lines once more. Disable, enable, disable, enable. Actually commenting, uncommenting, but whatever. And let's see if that is, now I have to make all, of course. Make all. And go. And unfortunately it still doesn't work. No signal change at all. So despite these efforts, nothing yet, but that leaves experimenting for next time, whatever that may bring. Final part, saying goodbye. Well, thank you for watching in this video where I have experienced some mistakes which I did, but also a firm reminder that the Raspberry Pi isn't just an ordinary computer. If you compare this to an ordinary Linux computer, it isn't. Raspbian isn't just any ordinary Linux version. It is tailored for Raspberry Pi. Hence the name Raspbian. But it is perfectly equipped for this stuff, and now with I2C enabled, I think I can solve it. Last test for this hasn't worked yet, but who knows, whatever comes along. Can I combine it with SPI? Well, this ADC analog to digital converter, I don't know. This is I2C anyway. Maybe I can read this with this. Nice idea. Who knows? Anyway, thank you for watching. If you like this video, please subscribe to my channel. Give it a thumbs up and leave a comment. You can also follow me on Twitter, and then retweet, like and leave a comment. You can also follow me on Instagram. Like and leave a comment. Sometimes I get a comment that is totally not understandable by me, but I'll ask then what it means. Please do answer. Do leave a comment. Please donate to keep videos coming to you. You can also become a patron and have your name mentioned, either on my website or with my video, depending on your pledge. And this is going to be continued. Thanks for watching. Bye bye.